Hello, this is Felix from GMWolf, and today I'm going to expand upon last video where I showed you how to make a very simple tire for a car game. And this video I will show you how you can actually attach those tires to a car and have your car drive around. So what we're actually going to do is have a very simple car shape, probably a square or something similar, and we're going to take our pre-existing tire object and just put a few over here, 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 and here, as you can probably guess. And we are going to be actually using revolute joints, which allows us to turn the front wheels back and forth, but keep them pinned against the car at a certain point. And this is exactly what a tire actually does. After that, we'll just add a very simple mechanic to turn the front tires and to add just a simple thrust, probably at the back tires or front tires, depending on if we're going to be using a front wheel drive or a back wheel drive. So I don't think there's much more explaining to do on the paint over here, so let's bring up the Game Maker project. So this is where we left off last time, so we can take off this piece of script right here. So let's delete that, because we just need the friction part. Now we will create a very simple sprite for the car. Let's make it 128 by 64 should be good enough. Let's just make it be some sort of square like so. Actually, to make things nice and neat, we will make this into this sort of square like so, being transparent so we can see through it, so that we can actually see the wheels better, and we'll center it and call it SPR_car. We can create a new object for the car. Let's call it obj_car. We want to use physics. We want it to be a box shape. Choose your sprite and modify the collision shape to make sure it is good. Next, we want to change the density and all this. So what we're going to do is leave most of this as it is, but change the density to maybe 100, because we had this. We used 65 for the tire, and 100 should be around about good. Maybe turn it down to 95 for the car. Of course, later on when we actually add proper cars, we like multiple cars, we'll actually do the research and apply the right density for different cars in order to make sure that we have appropriate speeds. Now, what we're going to do for the car is add inside the create event a script which will create the tires in the right position. So remember, we want to have our tires as so, and so what we will do is have the front left tire, and we'll create it. It's called create. Now I want to be x plus 32, and this is just going in accordance with the size of the car we chose. Roundabout, the size is not exactly perfect, but it will have to do. Y minus 28 and obj_tire. Now, so this will create it roundabout here at the top left corner of the sprite. Of course, this will have to be changed again with the different cars, etc. Now we want to create a joint, so the front left joint, I'm going to call it FLJ, is equal to physics underscore joint underscore revolute create. So this will create a joint between two objects, two physics objects, and so we're going to be using the first instance being the car itself, so we're going to use ID in order to reference the car that we just created, and the front left tire. Next, we want to choose the world anchor, which is whereabouts the revolute joint is, where it's going to pivot around. So we're going to be using front left tire dot x front left tire dot y, and then we want the lower angle limit and the upper angle limit. Now, for the front tires, we want them to turn about 25 degrees either side, so minus 25 and 25. Enable limit will be true. The max motor torque doesn't exactly matter because we're not actually going to be using a motor, but we could just set it to 2, for example. It doesn't really matter. I like setting things to 2. Motor speed will be 0, enable motor true, and collide instances will be 0 because we do not want our tire to collide with our car object. And finally, we need to disable the motor, so physics underscore joint enable motor, so the front left joint, so FLJ 0, so to disable it. Now we want to do the same thing for the front right tire, so just copy everything, paste it, change the L's to R's, over here, and over here. We also want to create it a different place. Instead of having minus 28, we want to have it plus 28. And that looks like that's good for the front tires. Now we want to create the back left tire, so back left tire, so BL tire. And we can actually just copy paste these two over here, just the 2 lines. We don't need the motors. As I said, the motors will be used later on, but we do not need them as of now. So it will be minus 32 and minus 28 for the front left tire, front left joint, and we wanted to change all these to back left, by the way. These are supposed to be back left and back left joint. Because they're at the back is minus 32, we want to change this to BL tire, BL tire.x, BL tire.y, and the rest shouldn't matter. We should change these over here to 0, 0 because we don't want to move them, and all of this we'll just replace with 0, 0, 0, and 0. And put spaces, of course, just to make it look better. We can now copy this one over for the back right tire. So instead of having minus 28, we want plus 28. Back right tire, back right tire, back right tire dot y. So just to recap, because I went quite quickly through this, we're basically creating our tire, one tire, at the place where we want the front left tire to be. We're creating the joint between our 2 cars, and we're doing the same for all the other tires in the right position. For the 2 front tires, we did add the lower angle limits and upper angle limits to minus 25 and 25 to make sure we can turn them. Now, right now, we're just going to have a car with tires, and we actually want to have the tires to turn, actually. So if the front tires turn on the side, we are going to have the effect we had with the the friction we added, so that it would only go in one direction then, with the code we have right here. And it is actually going to make the car turn. So let's go inside a new event. Let's go inside the step event, and let's add some very simple code. We're going to say, actually go back in the create event. Let's create a quick variable and call it tire underscore direction, or just tire dir, and let's set it to 0. And we're gonna have tire underscore max dir is equal to 25, and tire underscore min dir is equal to minus 25. Now, right now, we're actually going to be using a very simple method to change the direction of the tires instead of using motors. And that is because we are not going to have a lot of other interactions. However, later on, if we have the need to, because of other objects colliding with the car, etc., we're going to have to use motors with a really high strength, but a low enough strength so that when you get hit, the tires might not exactly stay in the right direction. So let's go back inside the step event code. And what we want to do is first of all get the direction of the keyboard is being pressed. So we're going to say dir is equal to keyboard underscore check, and we want to check VK right, and we're going to take this and take away keyboard underscore check VK underscore left. Now, normally when doing this kind of setup over here, where we check two different keys to find an axis, so you know, if we press left, it will be -1, and right +1, and if you press both of them, it's 0. The reason we're doing right and then left instead of left then right is because the directions, the rotations in Box 2D, which is the engine GameMaker uses for physics, actually are reversed. So you'll have to go clockwise instead of anti-clockwise. This is why we're using right and left over here. So now we want to actually change the tire dir, so we can go tire underscore dir. If I remember the thing correctly, let me just check. Tire dir, yes, that's the one. Is equal to clamp. So, and we want to have our value, which is going to be tire underscore dir plus dir, and we want to clamp it between tire underscore min dir. Was there an underscore? I can't remember. That was between tire min dir and tire underscore max dir. So the clamp will actually take the first value, and if it gets bigger or smaller than these two values, it will clamp it in between. Before that, before this was implemented, you might have seen min and max being used together, but now the clamp has been implemented, and it's a lot more efficient. Now that we have the tire dir, we also want to well, if dir is 0, we want the tires to come back to their normal position. And to do that, we're going to have if dir is equal to 0, we want to change the angle of our we want to make it go back towards 0, and I'm doing hand movements in the air, and I know it doesn't actually go on screen, but the way we're going to add this is by finding if the tire is greater or 0. We're going to find the sign of our current tire dir. So sign, so S, we're going to call it S, is equal to sign tire underscore dir. I didn't actually prepare for that particular part, but it should go fine. So the sign of tire dir basically means that if dir is greater than 1 or greater than 0, it will be 1, and if it's more than 0, it will be -1. And we then want to set tire underscore dir is equal to the smaller value, no, to the bigger value of the absolute value of tire dir, which is basically always making it positive. So the maximum of the absolute value of tire dir -1 and 0. So it will actually, let's change this to -3, so it's quite fast. So it will always be greater than 0, and then times S, so that if it was -1, it gets bigger, etc., etc. So I think that's it for the tie direction over here. All we have to do now is add actually set the angle of our physics joints, and to do so, we're going to use this this function over here, physics underscore, what was it? Joint underscore set value. And the joint we want to affect first is the front right tire, front right joint, sorry, not so FRJ. The field is physics underscore joint underscore upper underscore angle underscore limit, which is the limit of the well, the upper limit of the joint angle, as the name says, and we want it to be of dir. Sorry, tire dir. And we want to do the exact same thing, so let's copy and paste it for the lower angle limit. And then we're going to copy all of this, whoops, and paste it for the front left joint and the front left joints as well. So I think that's it. So to recap on this section of code, we first find the axes of the keyboard, which means if you're pressing right, it will be equal to 1, and if you're pressing left, it's -1, with this line of code over here on top. Then we set the tire direction to the tire dir plus dir, but we clamp it so that it's between the min dir and max dir, so it doesn't exceed -25 and +25. And then we're saying that if dir is not equal to 0, so if you are pressing a key, no, sorry, if you're not pressing a key, so if dir is equal to 0, then s is equal to the sign of tire dir, which is either 1 or -1, and then this line of code here will basically adjust the tire dir so it gets more and more towards 0. And then we just set the joint upper and lower limits using these 4 lines of code at the bottom. Now let's go back up here and check that this is -25 and +25. Good. I think that all we have to do now is simply place our object 1, which should be called obj car, inside the room and pressing play. Now the car will not move yet, we just made the tires move, that's all. But once it's finished compiling, you should be able to see that we have an error, which is always bad. Apparently he doesn't know what tire max dir is, so we will have to remedy this right now. I have no idea what went wrong. Oh, here you go. Here's the problem. I put an E after max dir. So here you go. I have to say the debugger is quite nice, and it tells you directly what the problem is, and I really like it. So let's see. Now it should work. And as you can see, we have our car with 4 tires, and if I press left and right, you can see the tires starting to move. Now I can press up, nothing happens because they didn't program that in yet. Now you can see there is a sort of problem, and it's that it doesn't turn very fast. So let's change that right now. Go into the step event, and instead of having just keyboard check VK right and VK left, at the very end we're going to times it by 3. So that should solve that problem. Now we actually want it to move forward and backwards, and to do that we will add in a new event, add event, keyboard up, and what we will program in here is that with the back left tire, BL tire, we want to add a force, so physics underscore apply, but instead of a normal force, we're going to be using a local force, which means that the force will be applied along the axes of the current object. So if the object has an angle of 0, it will just go straight. But if it's slightly rotated, it will still go along that rotated axis. It's quite hard to explain. So we want to have x local, which is going to be where along the objects. We want to have 0, 0, because it's going to be relative to our x position already. And the x local force we're going to set to 100. And I did forget the y local force, which would just be 0. And then we just copy this, paste it for the back right tire. This is the same as applying a force of 200 on the car, but it's more accurate that way. So if we press play now, drum roll, we should have our car coming up, and we can still turn the tires a lot faster. And if I press forward, the car starts moving. And if I press left, the tires turn, and the car actually moves around. and it's actually moving because of the physics behind it, not because I actually told it to change the angle, which is rather nice. As you can see, the car is quite slow, so let's remedy this by adding a bit of force over here. Let's change this to, maybe let's make it 3 times faster. Now, you might also want to change a few other values, but you can tweak around with a lot of the values and find what suits your game better. But I'm not going to figure out the sweet spots in this video. But at least putting the force up should make a large difference. As you can see, I can now move a lot better. And that is basically it, just for the basic car. I think that next video I will show how you can add a more realistic feel to the engine, how you can make the car move better, and if we have time, although it probably will be another yet again video, we will see how we can add different types of friction depending on different materials, etc. So I've been Felix from GMWolf, and thank you for watching. I'll see you guys next time for more videos.